Geometrical representation, chapter 11. So let's see what is the first problem here. Draw a circle of radius 6 centimeters from a point 10 centimeters away from its center. Construct the pair of tangents to the circle and measure their lengths. So we're constructing the pair of tangents to a circle and measure their lengths. So how do we do this? What is the solution of this? We'll just see. So solution. We'll draw the circle and then the tangents. So what are the steps of constructions? We'll see. First we construct a circle of radius 6 centimeters. The center O, then join 10 centimeters somewhere. So now what we are doing is we are drawing tangents to the circle. Yeah, what are the steps of construction? We'll see. This is the figure which we are having. This is the construction. While writing the steps, I'll just tell you all how did I do that. So the first one is construct a circle of radius 6 centimeters. That is given to us in the problem. Now in the second step, what will you all do is join PO. PO is an external point, and from a point 10 centimeters away from its center, we are drawing a line. OP is equal to 10 centimeters over here. So now this radius is equal to 3 centimeters. So from here, after 3, you are just drawing some 7 centimeters away from it. Then what we are doing is join PO. This OP is nothing but equal to 10 centimeters. It's an external point outside the circle. It is from the center of the circle to an external point. We are drawing a line which is we are bisecting and bisect it. After bisecting, let M be the midpoint of PO. How do we bisect this line? We take a convenient radius more than half the radius of OP, draw an arc up above and below the line OP, then again take P as the center, same radius, draw an arc meeting the previous arc up and below the line. So you then join both the arcs down and top, you will get a line. Therefore that line will be perpendicular to OP and also it will become the midpoint of OP. So we are going to bisect OP and let this point, bisecting point, be nothing but M. We are naming it as M. Now what is the third step is taking M as center and MO as radius, draw a circle, let it intersect the given circle at the points Q and R. Now in the fourth step, what we are doing is join PQ and PR. The fifth step, PQ and PR are the required two tangents. That is, we measure what is PQ is equal to PR. So we know that both of them will be equal because tangents drawn from an external point to a circle are always equal. So therefore now justification of this is what we'll see. Join OQ and OR. Since angle OQP and OQR are the angles in a semicircle, they are equal to 90. So therefore we have angle OQP is equal to 90 degrees, which is equal to angle ORP. This we have learned in the previous class, that the angle made in a semicircle is always 90 degrees. So also, since OQ and OR are radii of the circle, PQ and PR will be the tangents to the circle at Q and R respectively. So this is the justification part. Now going to the second problem. What's the second problem? Let's see here. Second one. Construct a tangent to a circle of radius 4 centimeters from a point on the concentric circle of radius 6 centimeters and measure its length. Also verify the measurement by actual calculation. So now how do we do this? We'll see. First I'll draw the figure, solution part. Let's see what are the steps of construction for this. So this is the figure. How to do this we'll just see. So steps of construction. So first we have to draw two concentric circles, one of radius 4 centimeters and the other 6 centimeters. So first draw concentric circles of 6 centimeters and 4 centimeters. You know, concentric circles will be one inside and one will be outside. So 4 centimeters inside, the external one is 6 centimeters. Now we are join P to O and bisect it. We are bisecting it also. Bisecting means we are taking with O as center and more than half the radius of OP, we are drawing an arc up and down, and with again the same radius and center P, we are drawing an arc meeting the previous arc up and down, and then join both where the two arcs have intersected above and below the line. We are joining that line. Please take correct measurements and do. I did with normal measurements here. How it was convenient for me to do, I did it in that way. So you will take the exact measurements, you will get the correct value of there. So then join and bisect it. Let capital M be the midpoint of PO. Now we got a perpendicular bisector, no? So that point is nothing but M. So let M be the midpoint of PO. Third step, taking M as center and radius MO, draw a circle. Now after drawing a circle, that circle is intersecting the given circle at the point Q and R. Okay, there are two circles over there. So it's intersecting at Q and R. So taking M as center and MO as radius, draw a circle. Let it intersect the given circle at the point Q and R. Fourth point is join PQ. By measurement, PQ is equal to 4.5 centimeters. PQ is the required length. Now by actual calculation, how much do we get? This is how we constructed. We got it as 4.5. Now doing it by actual calculation. So by actual calculation, what will we get? We'll just see. Actual calculation. PQ is equal to under root of OP square minus OQ square. So this is by Pythagoras theorem. Which is equal to under root of 6 square minus 4 square, which is equal to 36 minus 16, which is equal to root 20, which is equal to 4.47 centimeters. And this is nearly equal to 4.5, because if you are taking to the nearest tenth, then you can write it as 4.5. Now justification. Join OQ, then angle PQO, and angle in the semicircle is 90 degrees. And angle in the semicircle, therefore angle PQO is equal to 90 degrees, which implies that PQ is perpendicular to OQ. Since OQ is the radius of the given circle, PQ has to be a tangent to the circle. PQ has to be the tangent to the circle. Next, going into the third one, draw a circle of radius 3 centimeters. Take 2 points at a distance of 7 centimeters from its center. Draw tangents to the circle. From these 2 points P and Q. So now what is the solution? We'll just see how to do this. So steps of construction. First one, draw a circle of radius 3. Draw a circle of radius 3 centimeters. Then in the second step, what will you do is take 2 points at a distance of 7 centimeters from its center. Then third one, bisect PQ. Bisect PQ, let O be the you're bisecting PQ means O is the midpoint. So let M be the midpoint of PO. That means we are taking one center. From the center O, you are drawing 7 centimeters one side, and the other side, it is because 3 centimeters over here, already the radius of the circle is 3 centimeters. So from O, you are taking total distance is 7 centimeters, that is P. And again from this side O towards the left side, you are taking it as 7 centimeters, that is OQ. So now here you are taking 2 points from the center, the other side. One is the right hand side, one is the left hand side. So you are going to draw a line that is PQ, bisect PQ, that is O itself is the center there, we can see, because that is the point. From O we have taken 7 that side, 7 this side. So after bisecting PQ, let M be the midpoint of PO. We are bisecting PO here first. Okay, so bisect. Okay, we'll take it instead of taking it as PQ, let M be the midpoint of PO. Then again next, in the next point, in the fourth point, taking M as center and MO as radius, draw a circle which intersects the given circle at the points A and B. Given circle at the points A and B. The next fifth point is join P to A and P to B. Now PA and PB are the required tangents. PA and PB are the required tangents from P. Tangents from the external point P. Next, sixth one, again now we are going to bisect QO. So bisect QO, let N be the midpoint of QO So you can see that N is the midpoint. Now with N as center and ON as radius, draw a circle meeting the first circle at the point C and D. So now here we write now next point is taking N as center and NO as radius, draw a circle, let it intersect the given circle at the points C and D. Now join QC and QD. Then QC and QD are the required two tangents. Justification. Join OA and OB. Then angle PAO is an angle in the semicircle and therefore angle PAO is equal to 90 degrees, which implies that PA is perpendicular to OA. Since OA is a radius of the given circle, QC has to be the tangent to the circle. Similarly, QD is also a tangent, to the circle. Now going into the fourth one. Draw a pair of tangents to a circle of radius 5 centimeters which are inclined to each other at an angle of 60 degrees. Construction for this. So in the first step, what we are doing is take a point O on the plane of the paper and draw a circle of radius OA equal to 5 centimeters. So first we draw OA is equal to 5 centimeters circle of radius 5 centimeters circle. Then second one, produce OA to B. This point is B, I'm sorry. This is B. OA to B such that OA is equal to AB is equal to 5 centimeters. Now third point, taking A as center, and your radius will be, draw a circle of radius OA equal to AB equal to 5 centimeters. Taking A as center, draw a circle of radius AO is equal to AB is equal to 5 centimeters. It cuts the circle at P and Q. Join BP and BQ to get the desired tangents. Now what is the justification? We'll see. In triangle OAP, we have OA is equal to OP is equal to 5 centimeters, which is equal to the radius. Also we have AP is equal to 5 centimeters, radii of the circle. Therefore triangle OAP is equilateral, which implies that angle PAO is equal to 60 degrees, which implies that angle BAP is equal to 120 degrees. So in triangle BAP, we have BA is equal to AP and angle BAP is equal to 120 degrees. So therefore angle ABP is equal to angle APB, which is equal to 30 degrees, which implies that angle BPBQ is equal to 60 degrees. Hence proved. Okay, going to the next one, fifth one. Draw a line segment AB of length 8 centimeters, taking A as center, draw a circle of radius 4 centimeters and taking B as center, draw another circle from the center of draw another circle of radius 3 centimeters. Construct tangents to each circle from the center of the other circle. Now solution, what is the solution? We'll see. Now we'll see what are the steps of construction for this. Steps of construction. So first step is draw a line segment AB equal to 8 centimeters. Second, draw a circle with center A and radius 4 centimeters. Draw another circle with center B and radius 3 centimeters. Let M be the midpoint of AB. Let M be the midpoint of AB, taking M as center and AM as radius. Draw a circle which intersects the circles at P, Q, R and S. So first what we are doing, we are drawing a line segment AB which is equal to 8 centimeters. We are drawing a circle with center A and radius 4 centimeters. With center A, you are taking 4 centimeters radius and you are drawing one circle. With center B, you are taking a radius of 3 centimeters and drawing. Then you take the midpoint from M and AM as the radius. You draw a circle with M as center and AM as the radius. Draw a circle touching the two circles which intersects the circles at the point P, Q, R and S. So now the last step is, what do we do? The next one is join AP, AQ, BR and BS. These are the required tangents. Now going in the sixth problem. Let ABC be a right angle in which AB is equal to 6 centimeters, BC is equal to 8 centimeters and angle B is equal to 90 degrees. BD is the perpendicular from B on AC. The circle through B, C, D is drawn. Construct the tangents from A to this circle. Now we'll go into the solution part. Before that, we'll draw the figure. Now steps of constructions for this. Steps of construction. First, draw a line segment. BC is equal to 4 centimeters and AB is equal to 3 centimeters. perpendicular to each other. These two lines are perpendicular to each other. First what we do is we draw a line BC which is 4 centimeters. Then put the protractor at B, or if you can do with the compass, make an angle of 90 degrees with the protractor and you draw a straight line. You will get that AB is perpendicular to BC, so the angle ABC is a right angle triangle. Angle ABC is equal to 90 degrees. So now join A to C, and here triangle ABC is the right triangle. Now we got a triangle first. Then now in the second step, taking the midpoint E of BC as center, draw a circle with radius B equal to EC equal to 2 centimeters, passing through B, C and D. At B, that is AB is perpendicular to BC. Its length AB is equal to 3 centimeters. Now taking center A, draw an arc of 3 centimeters, AB equal to AF. Taking center A, draw an arc of 3 centimeters, that is AB is equal to AF, cutting the circle at F. So join AF and AB are the required tangents. Now going into the seventh problem, you can see from the figure also. First what we are doing, we are taking a line segment BC, then perpendicular to that we are drawing one more line AB which is 3 centimeters, BC is equal to 4 centimeters, and this AB is equal to 3 centimeters. Then we take the center of BC, that is E. EB is equal to EC which is equal to 2 centimeters, with E as center and EB as radius. We are again we are joining from A to C. First join A to C, then with E as center and EB as radius or EC as radius, draw a circle in such a way that it meets B, C and D, touches these points. Then what do we do is, now we have to find out tangents from the external point A to the circle. So now you know one AB is a tangent to the circle, so therefore you take the length of this AB, it is 3 centimeters. The same with A as center and 3 centimeters radius, draw an arc onto the circle on the other side so that it meets at F. Now join AF. AF and AB are the required tangents. Now going into the seventh problem, draw a circle with the help of a bangle. Take a point outside the circle, construct the pair of tangents from this point to the circle. So now what is the solution? We'll just see. For this, draw a circle with the help of a bangle. Then second step, draw two chords AB and AC. This is B, not this. This part is B, not this. And AC is over here. This is A. AB and AC, two chords perpendicular. Then we have to find the perpendicular bisectors. Perpendicular bisectors of AB and AC. So now we having two chords AB and AC intersect each other at O, which is the center of the circle. So for a bangle, how do we find out the center of the circle? Is by taking that perpendicular bisectors of the two chords, we find out the center of the circle. After finding out the center, by default I have just drawn a circle and I have taken the center in a different way. So you have do it perfectly. Take two chords, draw perpendicular bisectors of both the chords. Where they intersect, that point is nothing but the center of the circle. So then after drawing the center of the circle, what do we do is, now taking a point P outside the circle, join O to P. Now let M be the midpoint of OP, taking M as center. Please follow the steps of construction more than the figure, because the figure is more accurately I have drawn to the measurements, not perfect measurements. If I take perfect measurements, I don't get those all those compass and everything. I don't have those measuring instruments with me. So taking M as center and OM as radius, draw a circle which intersects the given circle at Q and R. Now join PQ and PR. Thus PQ and PR are the required tangents. So this